Betaflight 4.2 is just around the corner. As of today, release candidate number 1 is out and people are already trying it. People who are brave enough to take a risk on a release candidate. They usually don't have bugs, but if they definitely didn't have bugs, they'd be a release, not a release candidate. With Betaflight 4.2 just around the corner, I think it's time for us to take a deep dive into the release notes of Betaflight 4.2 and see what all of the new stuff it brings to the table are. And this is a really interesting release because most of the things in Betaflight 4.2 are not like sexy, exciting. Did I just call a flight control firmware sexy? Yes. There are some sexy features in some versions of Betaflight, like RPM filtering. Oh my God, RPM filtering was so good in Betaflight 4.1. And in 4.2, I don't think there's like one killer feature, but there's a whole lot of stuff going on under the hood that are just going to make your quad fly better. It's like instead of Betaflight 4.1, which was kind of like cake, Betaflight 4.2 is kind of like brushing your teeth. But nobody likes cavities. I'm Joshua Bardwell, and I've carried this metaphor way too far. This video is part of my playlist, my Betaflight 4.2 playlist. It's linked in the video description, and it's where all my Betaflight 4.2 videos are going to go. As Betaflight 4.2 comes out, we'll do some flight testing. We'll do some deep dives into some of these features. I've already got a few videos stacked up based on the release candidates, though. And if you want to finish this one, you want to check out some of the other stuff, it's linked in the video description. And what I want to do in this video is just take you through the release notes of Betaflight 4.2 and talk about some of the new features that are coming. And I feel a little bit guilty because there's a part of my brain that goes, Joshua, you just read in the release notes. That's a little bit of truth to that, but some people would rather have me read them the release notes, like on your drive to work or something, than read them yourself. And I'll add my commentary, of course, as we go. But if you'd rather just read the release notes and the tuning guide yourself, there's a link in the video description. And be my guest, no hard feelings. Let's do it. So, Betaflight 4.2 Release Candidate 1. There are changes to how targets are downloaded and installed. You do need to be using the latest release of Betaflight Configurator if you're going to install Betaflight 4.2. The latest configurator version is 10.7.0. It is also currently in release candidate. If you're going to try Betaflight 4.2, you should also install 10.7.0. Link in the video description. I better keep track of all these links I keep saying I'm going to put in the video description because I'm up to like 7 already. If you're using Blackbox Explorer, there's an updated version of that as well. Link in the video description. If you use Betaflight's Lua scripts, you need to update them as well. This is a common mistake that people make. They update Betaflight, but they don't update the Lua scripts on their radio, on the SD card of their radio. And the Betaflight, the OpenTX version, the Betaflight version, and the Lua script version are all interlinked. So if you update OpenTX on your radio, but you don't update your Lua scripts, or they can get out of sync and it's really kind of a mess. The absolute best thing you can do is to be on the latest version of Betaflight, the most up-to-date version of the Lua scripts, and the latest OpenTX version at any given time. And if you ever have trouble with the Lua scripts, try that. Kind of sucks that you have to update a whole bunch of stuff just to get them working sometimes. There's a detailed tuning notes, which we will be taking a look at in this video. But a warning, if you're coming from a previous version of Betaflight, please do not paste your tune from previous versions into Betaflight 4.2. There are some things you can paste in. I've got a video about updating from 4.0 to 4.1, which shows you the safe parts of your config dump, like your aux modes are safe to paste in. Nothing's changed there. Your rates are safe to paste in. But other parts, specifically stuff related to the PIDs, are not safe to paste in because so many things have changed. You will, at least at the beginning, be starting with the defaults and then tune from there. But the good news is the defaults on 4.2 are supposed to be, hopefully they'll live up to this, they're supposed to be better than they ever have been. So hopefully you get a better flying quad in exchange for not being able to carry forward your like perfect tune. Betaflight used to default to one-shot 125 as its default motor protocol, and that always annoyed me because, well, not always. It used to be that one-shot 125 was the newest, hottest thing, but that was years ago. When was the last time you saw an ESC that didn't support at least dshot 150? And dshot avoids any issues with calibration, and dshot solves so many problems as long as your ESC supports it. I have long thought that it was time to change the default motor protocol to dshot 150 at least. And now they've they've set it to disabled, and you'll need to set it yourself. But at least it's not one-shot anymore. When enabling bidirectional dshot, the maximum possible PID loop speed for dshot protocols will be reduced by half. Here's what's going on. If you try to run dshot 600 with bidirectional dshot, bidirectional means that for every packet that's sent, a packet of data comes back. And if you're running dshot 600, that can be so fast that a bunch of the packets can get corrupted because there isn't enough time to send back the responses. And what you were supposed to do is turn your PID loop rate down. Instead of running at 8K, you might run it at 4K, and then that gets rid of the error packets. Well, basically now Betaflight just does that for you automatically instead of you having to do it. And I'm going to guess that a whole lot of people didn't even know you were supposed to be doing that, and now Betaflight will do it for you automatically, so you don't have to worry about it. Betaflight has a feature called yaw spin recovery. There's a bug in the gyro chip used by Betaflight that results in a condition called yaw spin to the moon. Basically what happens is if you spin the quadcopter too fast, faster than the gyro can read, it thinks it's spinning to the right when really it's spinning to the left. And then when it tries to slow down, it spins to the left, which makes it speed up. And then the quadcopter flies away to the moon and never until you disarm. Betaflight has yaw spin detection and prevention, and it has previously been set at, I think it's like 1900 or 1950 degrees per second when the maximum is 2000. But the problem is that in some cases, you'll blow past that threshold and you'll get a yaw spin to the moon, and then that's bad. You never want an out of control quad. What Betaflight 4.2 does is looks at your yaw rate, and it says, if your maximum yaw rate is, let's say, 900 degrees per second, 800 degrees per second, then we don't need to have the yaw spin threshold all the way up around 2000 degrees per second. We should never be going that fast. So it automatically sets the yaw rate for yaw spin protection based on your actual yaw rate. And that means that yaw spins are even less likely than before. Accelerometer calibration is required before arming is allowed if any feature is enabled that requires the accelerometer. This is something that iNav has done forever. You have to calibrate the sensors before you fly. Betaflight has let you get away with not calibrating the accelerometer, and that could result in a situation where you go into angle mode, and instead of going flat and level, the quad goes like this and tries to fly away. By forcing you to calibrate the accelerometer before you use it, Betaflight is ensuring that quad's going to not surprise you. The calculation for the virtual current meter device has been changed to be based on the throttle value used in the mixer instead of the throttle channel RC input. I'm so tempted to skip this bullet point because it's so esoteric. And are you using the virtual current sensor? Very few people are using it. If you don't have a current sensor on your ESC, there's a thing called the virtual current sensor, which approximates the amount of current that the motors are using based on the throttle position. And the way that it has worked is it's based directly on the stick position. But if you're using something like throttle scaling or motor output scaling, full throttle isn't full throttle anymore. And the current meter should scale itself down accordingly. Well, now it does. So now the virtual current sensor scales downwards as you apply throttle scaling or motor output scaling, whereas before it didn't. The way that the RSSI dBm value is tracked in the firmware has changed to use the actual dBm value in a range of -130 to 0 instead of the previous version, which went from 0 to 130. dBm or dB, decibel milliwatts, are a very confusing unit unless you're like an RF engineer. Instead of like starting at 0 and counting up to 100 like you kind of would expect, they start at 0 and they go down. So 0 is the strongest and -130 is the weakest. And in the past, Betaflight hasn't actually tracked them that way. Now it is. So two things to keep in mind. It's going to go down as it gets weaker, but the number is going to get bigger, right? Which number is bigger, -10 or -130? -10 is more, because it's negative numbers. And if you have any threshold set, if you have the threshold set at 70, you're going to need to change it to negative 70. Stick arming has now been disabled in Betaflight by default. Is stick arming still a thing? What even is stick arming? Yeah, I'll bet some people have never used stick arming. It's been that long. Stick arming goes back to the days when we only had 4-channel receivers. Cheap 8 or 16 channel receivers have been around for so long that I bet a lot of people don't even remember this. In order to arm the quad, you didn't flip a switch because you didn't have any switches. You would push the sticks down and inward, or it's actually yaw down and to the right. Sorry, down and inward is like DJI. The problem with stick arming is that in order to go down and to the right to disarm, you have to disable the yaw channel. Otherwise, when you go to disarm the quad, you'll go full yaw to the right and the quad will go and spin. Well, you wouldn't want that. And the problem is that when you lower the stick, then the yaw channel is disabled. And if that happens when you're flying, it's bad. The yaw channel is disabled. So it can also result, if you try to do a yaw spin while you have stick arming enabled, you could just disable the quad in midair by trying to do a yaw spin. So stick arming is disabled. If you need to re-enable it for some weird reason, you can do it in the CLI. But don't. Next, we get to the major and minor features of Betaflight 4.2. And after we go over those, we'll go over to the tuning notes and discuss some of the tuning things that you're going to want to think about if you decide that the default tune for Betaflight 4.2, you want to try and improve it. And the major features here are so under the hood and so important, but also all that's going to happen is your quad's going to fly much better, hopefully. It's not going to like knock your socks off with some new shiny, sexy feature. And the major thing that's happened is that the gyro loop has been completely reworked with the goal of making the gyro sampling and PID loop as consistent as possible. And by consistent, we mean the timing. When we say that the gyro needs to be sampling at 8 kilohertz or the PID loop needs to be running at 4 kilohertz, what if it's not running at 4,000 hertz? What if it's running at 4,005 hertz or 4,100 hertz or 30, what if it's slightly off? That actually matters when we're doing RPM filtering, which is one of the most powerful and beneficial features of Betaflight 4.1. RPM filtering makes your quad fly great with cool motors and no prop wash, but the RPM filters need to accurately target the motor frequencies. And if the PID loop is not going at exactly the frequency that it thinks that it is, then the calculation of the RPM filters will be off. So instead of targeting the motor frequencies exactly, you'll be slightly lower or slightly higher, and the effectiveness of the RPM filter is reduced. So all of these changes are designed to make the RPM filtering work much, much better. And that's why I say they're like probably not going to knock your socks off, just your quad's going to fly much better. Betaflight has added 2 new rate calculation modes, actual and quick. Those are discussed in a separate video, but basically I link in the video description, but basically actual and quick rates let you adjust your center stick and your full stick rates independently, which is kind of how everybody thinks of them anyway, but it's not how the rate calculation has worked in the past. So check out my video about that if you want to have a more intuitive way of adjusting your rates. Added compensation for sagging battery voltage resulting in more consistent throttle/PID behavior over the entire flight time. Here's the problem that this is designed to solve. Have you ever noticed when you first plug in your battery, your throttle is super punchy and your quad feels super responsive? And then as the battery gets lower, the throttle gets saggy. And like you'll hit the throttle and instead of the quad, boom, popping up, it'll kind of, And that can get you in trouble. Like you do a big split S over a tree at the end of a pack and you hit the throttle at the very last minute. And instead of the quad going and flying out of it, it goes into the ground because the battery was low. Throttle voltage compensation takes care of that. What it does is at the beginning of the pack, it kind of scales the throttle back so the quad has approximately the same throttle response as it will at the end of the pack. That doesn't mean that the quad just feels saggy all the time, but it does mean that you won't get surprised as the battery gets lower and the throttle response changes. The throttle response will be roughly the same from full voltage all the way down to whatever, 3.5, 3.6 volts whenever you stop flying. If you use this, it is really important that you monitor your voltage somehow, like with the OSD or with telemetry alarms, because there's this problem that 6S batteries have had, 6S low kV. The biggest problem is that you don't feel any voltage sag until the very end of the pack, and then you just destroyed your battery. And this new voltage compensation feature is going to make that happen for everybody. So even if you're flying 4S, you'll have consistent stick feel all the way to the end, and then if you're not paying attention, you just kill your battery. So definitely keep an eye on that. But this is going to be especially important, I think, for racers who need consistent stick feel across the entire battery discharge range. It's worth pointing out that if you read the pull request for this feature, eTracer, one of the devs, didn't feel like this was a good approach. And his objection was that basing a response, increasing throttle, on the thing that's affected by the response, voltage sag, is just not a good approach. In other words, as you punch the throttle, the voltage goes down, therefore the throttle boost goes up, and he's worried that that could create a feedback loop where anyway. But the people who flew it all pretty much seem to like it, and eTracer's objection seems to be mostly philosophical. Therefore, but it is turned off by default in Betaflight 4.2, and if you want to turn it on, you can see how to do it here in the tuning notes, which we'll get to in a second. Added level race mode, also known as NFE race mode in Silverware. TinyWhoop pilots famously race mostly in angle or auto level mode, but there's this thing that some of them have been doing, came from the Silverware firmware, where the pitch axis is actually acro mode, and the roll axis is angle mode. And I haven't never tried it, but I'm not sure why that's better. I guess it means that you can kind of nudge the nose up or down to go faster or slower, but still get, I don't know. Anyway, it's there and you can try it out if you want to. Some TinyWhoop racers really seem to like it. The only minor feature that I want to actually focus on is this one. The other ones, I don't even know what the point of them is. I'm sure there is a point, but I don't know what it is. And anyway, the minor feature I want to focus on is the ability to display the OSD logo upon arming. So if you go into the OSD tab and you go to the font manager, you can upload a custom OSD logo, like a pilot logo. And normally you only see that when you first plug in the battery, which is kind of lame because nobody's looking at your feed anyway. So being able to display the logo when you first arm the quad, or every time you arm the quad, it's up to you, means that people can see your awesome pilot logo if they're watching your feed. This is going to be really fun at events like International Open or big races where lots of people are spectating, or heck, even if you just share DVR of your awesome exploits, people will see your logo when you first arm. That's turned off by default. You can turn it on in the CLI. And now we come to the Betaflight 4.2 tuning notes. And a lot of this stuff is going to overlap with stuff we've talked about before, but there are some specific guidelines in here for how you might want to change the defaults under certain conditions that I think definitely need to be called out. And the first thing I want to really hit is that none of this stuff is mandatory. The defaults should fly well for most people under most conditions. Some people see this and they just freak out and they're like, Betaflight's too complicated. This is only here for people who want to look under the hood and want to tweak these values for certain specific conditions. And we're just going to start with these 5 notes from the devs. Number 1, do not paste in a diff or dump from any build prior to 4.2 in the CLI. Specifically, don't paste any PID or filter related stuff. Personally, I'm still going to be pasting in my aux modes because that's probably safe. Again, I have a video about going from Betaflight 4.0 to 4.1 about which specific parts of the CLI dump are probably safe for you to carry forward. And that's linked in the video description if you want to try and figure that out. The risk is on you if you decide to do that. The safest thing to do is to start from a fresh default build. Note number 2 relates to this dynamic notch filter setting in Betaflight 4.2. In Betaflight 4.1, there was a preset here where you set the notch filter to low, medium, or high. Now they're manually giving you the min and max hertz that you can set it to. The equivalent value for the maximum is either 350 if you had set that to low, or 700 if you had set that to high. And we're just going to enter that value here. based on what you previously had it set to. The main time that you would have changed that is if you're using RPM filtering. The guideline was if you're using RPM filtering, then you don't need the dynamic notch filter anymore to clean up the motors. So you set the dynamic notch filter to low to cause it to clean up some low and mid frequency noise, since the RPM filter is handling the motors. So basically for people using RPM filter, the setting would be 0, a Q of 250, a min hertz of, I think it was 70 was recommended, and a max hertz of 350. This would be used for most people who are using RPM filters. And if otherwise, you would just leave it at the defaults. In Betaflight 4.1, the anti-gravity feature was tied to the eye gain. So as you raised the eye gain, anti-gravity got stronger. In Betaflight 4.2, anti-gravity has been decoupled from the eye gain. So if you had unusually high eye gain before, you may need to raise the anti-gravity gain in Betaflight 4.2, since now raising the eye gain no longer has the effect of raising the anti-gravity gain. If you weren't running particularly high eye gains before, you may not need to, the defaults may be fine for you. The single best thing that you can do to get your quad flying its best under Betaflight 4.1 and 4.2 is to enable bidirectional dshot and RPM filtering. I have a video about how to do this. I strongly recommend, if you haven't already started using RPM filtering, that you go watch that video and you get it set up. If you're using BLHeli32 ESCs, you already have everything you need to support this feature. If you're using BLHeli S ESCs, you can still take advantage of the feature by using JESC and Jazz Maverick firmware. I have videos about all of this. They're linked in the video description, and I strongly recommend you use this feature. Don't start PID tuning. Just use default PIDs. The very first thing you want to do is get RPM filters working and then move the filter sliders to the right. I have a video about tuning the RPM filter as well as getting it working. And that is the single biggest thing you can do to get your quad flying great before you even touch any of the P, the I, the D, or any of this other nonsense. The next thing in the tuning guide are some quick settings. These are code snippets that you can copy and paste into the CLI. Just paste them into the CLI and then type save, and they will give you some presets that you may want to try out. The Pro Race preset is a very, very sharp stick feel, but requires a really clean RC signal. So you need to be using Crossfire with Crossfire Shot and locked 150 hertz sampling. If you're using something like FreeSky R9, for example, which is known to have a really, really sort of dirty signal that has a lot of corrupted packets and jitter, you wouldn't want to use this. The Race Fast Freestyle has strong feed forward, but is a little bit more forgiveness of a typical, not perfectly clean RC signal. The HD preset is ultra smooth and low turn rate. So for basically high definition and, well, I was about to say cinematic, but there's actually a cinematic preset as well for really slow turns only, and not for anything like normal freestyle. So HD is probably for HD freestyle smoothness. Cinematic is for no freestyle at all, just like flying a Cinewhoop as slow and smooth as possible. One of the biggest problems in Betaflight 4.1 that people struggled with was little wiggles and jiggles, mid-throttle oscillations, and many people found them very, very difficult to tune out. Here are some tips in the tuning guide for, if you have those problems, how to get rid of them. So that's going to be here in the PID tuning tab. In PID profile settings, you have the option here is D min. We can just disable that option. Setting D about 20% above P using the PD ratio slider. So this is another change in Betaflight 4.2, which is that the PD balance slider has been tweaked to adjust the D gain only while leaving the P gain alone. It used to adjust the P gain, and that's actually not how most people are tuning. Most people will get their P gain dialed in about where they want it and then raise or lower their D gain while leaving their P gain alone. Finally, this slider actually, if you just say, I just want a little more D gain, well, you could do that. And they suggest perhaps raising the PD balance to 1.2, which slightly increases the D gain. Setting TPA to D only to start at your cruising throttle value and increase the cut percentage a little. So if we go to the CLI here and we type get TPA, we can see the TPA underscore mode parameter, and that determines whether TPA will affect D only or P and D. If you don't already know, TPA is throttle PID attenuation, which causes the gains of the P and the D value to be reduced as the throttle goes up. The idea being that as the motors go to higher RPM, the motors make more thrust, and it kind of amplifies the effect of the PIDs. So we dial down the PIDs as the throttle goes up. And by default, TPA mode affects the D gain only, and that is actually, that's what they're suggesting. So good. And they're saying here in the rate profile settings to set the TPA to begin, that's the TPA breakpoint, to begin at your cruising throttle. So just figure out what throttle point you usually cruise at and set that to the TPA breakpoint, and then raise the percentage a little bit from like 0.65 to like 0.75 and see if that helps smooth out those wobbles. The next selection is setting the D low pass expo value as high as possible. You'll be limited by mid-throttle D noise. I feel like that one is complicated enough to not suggest here just in a quick run through, because mid-throttle D noise is a topic that's going to require some flight testing in black box to demonstrate. So I'm going to skip that one. The next recommendation is likely with the higher D gain, you'll need to filter D a bit more than usual. 2 clicks left on the D filter slider. So here in the PID profile settings, they've suggested we raise the D gain just a little bit by about 20%. That's going to make more D-term noise and hotter motors. So we're going to go to the filter settings, and we're going to take the D-term filter multiplier, and we're going to lower that down just a bit. In general, filtering the D-term more can help smooth out those wobbles. Lowering P gain can turn those wobbles down as well. So we'll go back over to the PID profile settings, and we will turn the PD gain down to about 80%. And that's going to lower both the P and the D, and that can also help. And then we start to get into what, to me at least, feels like a little bit esoteric, like lowering the I gain to almost half. Well, that might clear up these mid-throttle wobbles, but it also might make your quads sort of super floppy. And I'm not sure, by the time I got to that point, I might be looking other places. So the rest of these, I think we're going to leave out of the video for now, because I don't 100% feel confident. All of the previous ones are things that I've suggested before and seen work. These ones feel like we're getting a little bit far out there. The next thing in the tuning guide are these 2 code snippets. This one will return everything to defaults. If you've been screwing around with these settings and you just want to go back to defaults without wiping your whole config, paste this into the CLI and type save. And if you want to try out all of these features in one go without sort of turning them on and off and tweaking them individually, here is a code snippet you can paste. And this will give you the sort of full Betaflight 4.2 goodness. Some of these features are new enough that they weren't turned on by default in Betaflight 4.2, so you're actually not getting all the potential goodness, but maybe it'll cause some problems for some people. One of the biggest things that Betaflight 4.2 has tried to fix is problems with inconsistent RC input. In other words, your receiver is spitting out these packets of data every so many milliseconds, and those packets of data contain the stick positions. But if one of those packets is corrupted, or if there is inconsistent timing between the packets for any reason, that can create problems with it looks to the PID loop like you moved your stick suddenly, or like you didn't move your stick at all for a second and then jerked it. And those non-smooth motions can result in mid-throttle oscillation. They can result in unsmooth motors and other problems. The absolute best case scenario is if you're using a very, very high quality RC link that just doesn't drop packets and has very consistent timing. The best example of this today is Crossfire Shot, which requires a nightly build of OpenTX and isn't even fully released. But if you are using Crossfire Shot with locked 150 Hertz sampling, you get really, really consistent RC inputs. For everybody else, Betaflight 4.2 has a whole bunch of changes under the hood to help try to compensate for the kind of crappy RC input that we've been giving it. And one of the things they've done is they have improved feed forward. Feed forward is a part of the PID loop that freaks out when the RC input is not really consistent. And the most important of these parameters is FF_interpolated SP. This determines how the feed forward trace is going to be filtered to remove the unwanted spikes that occur when the RC input is inconsistent. The default value is average_2, which is a 2-point moving average, which is a good balance between reduced spikiness, but also not too much latency. See, the thing is, if you over filter the feed forward trace, then it gets super soft and delayed, and that's the whole point of feed forward, is that it's sharp and fast and responsive. So we want to get rid of the problems, but we don't want to just kind of neuter it entirely. Now, averaged 2 is the default, and it's what's recommended for general purpose flying. But if you know that you're going to be doing a certain type of flying, you can choose to go into the command line and change this. FF interpolated SP set to on would be used for racing, where you want the absolute sharpest stick response and the most responsiveness, and you're willing to trade a little bit of maybe mid-throttle oscillation or dirty motors in order to get it. Average 3 and average 4 are used when you're wanting to slant more towards smoothness and away from responsiveness, or if you know that you have a particularly noisy RC input, such as if you're using FreeSky R9. The most significant of these that I want to call out is that if you're a typical freestyle pilot flying with an HD camera, you may want to change this to average 3 from the default of average 2. You'll sacrifice a little bit of stick feel, but so many people have had so many problems with mid-throttle oscillations and jitter in Betaflight 4.1, and a lot of that may come back to that they've actually have a really cruddy RC input. And Betaflight 4.1 didn't have any means of sort of dialing back its responsiveness to deal with that. We mentioned dynamic battery sag compensation previously in this video. There are a few parameters you may want to tweak if you're using it. The simplest thing to do is to simply turn it on by entering set VBAT sag compensation equals 100 and set VBAT PID gain equals off in the CLI. A value of 100 means 100% compensation for voltage sag. So between a 4.2 volt cell and a 3.8 volt cell, that's about a 16% drop in voltage. 3.5. And what Betaflight will do with 100% VBAT sag compensation is at full voltage, it will reduce your motor outputs by about 16%. And that means that, and then as the voltage drops, it'll bring them back up again. And that keeps the motors feeling consistent across the whole battery discharge curve. You may choose not to fully compensate for voltage sag. For example, if you were to set VBAT sag compensation to 50, you would get 50% compensation at full throttle, and the battery would feel just a little more punchy. But then as you come down to 3.5 volts, it will feel more consistent. It's up to you if you want a little bit, if you want to feel a little bit of that sag as the battery gets down, or if you want 100% compensation. The other thing to keep in mind is that both throttle and motor output limits may need to be adjusted after you enable sag compensation. So if you're flying 6S batteries on like 2400 kV motors, but you're flying with a 66% throttle limit to bring the RPM down so it feels more like a 4S quad, the VBAT compensation will take it down by another 16% below that. So you may want to reduce your motor output limit just a little bit to give you you've got RPM to spare in that case. You don't need to bring it back down even further. And there are a few more things in the tuning guide, but as I look at them, either I've already covered some of them or the other ones are things that I think probably most people aren't going to touch. So I think we're going to call it there as if we haven't gone long enough already. I hope you've enjoyed this video. If you're still watching or listening at this point, I guess you must be a humongous nerd just like me who is really interested in all these details. That's one of the things I love the most about Betaflight is just getting to sort of get my hands into all these details and hear about all the changes that are being made. I like it. And I guess if you're still watching, you do too. That's going to do it for this video. I'll be making a few more videos going into some of the details on some of these once Betaflight is actually released and we can do some flight testing. For the time being, I'm holding off in case some of these things change between now and when Betaflight actually releases. That's going to do it for this video. Boy, more than do it. Thank you so much for watching and happy flying.